Hey there, and welcome to this explainer. I'm so thrilled to have you here today because we're going to unpack something absolutely fascinating. Right now, all across the globe, there's this unseen massive underwater choreography taking place. It's a continuous process of underwater excavation that quite literally keeps our modern global economy afloat. Without it, the mega ships carrying our goods would run straight aground, and our coastal cities would be entirely reshaped by the tides. So today, we're building your knowledge on the foundations of dredging, starting from absolute scratch.
Okay, let's dive into our step-by-step syllabus for today. First, core definitions and purpose. Second, mechanical dredgers. Third, hydraulic dredgers. Fourth, the 4 dredging phases. And finally, beneficial uses of sediment. Let's kick things off with Section 1, core definitions and purpose.
So let's start right at the beginning with our absolute basic concepts. Before we even look at the giant ships and the heavy machinery, here are your foundational building blocks. What is dredging? Well, dredging is simply the process of underwater excavation of soils and rocks. Essentially, it's moving dirt, but underwater. Now, the key metric you really need to know to understand this industry is called production. And production is exactly what it sounds like. It's the quantity of soil moved per unit of time. When engineers evaluate these massive machines, they are constantly measuring their production. They're asking, how much earth can this specific piece of equipment relocate in a single hour? But you might be wondering, why go to all this effort and expense? Well, dredging is absolutely essential to human infrastructure. We dredge to maintain navigation channels so those massive deep draft vessels can actually pass through safely. We do it for land reclamation, building new foundations for growing cities, and for environmental cleanup, to remove contaminated sediments. We literally even rely on it to protect our beaches from erosion and to control flooding by managing tidal flows in rivers. Without this process, honestly, our shipping lanes would just choke with silt, and our coastal habitats would wash completely away.
Moving right along to Section 2, mechanical dredgers, also known as the diggers.
Okay, so now that we know the why, let's look at the how. To give you a really clear mental map, the dredging world is basically split into 2 distinct categories based on how they actually excavate. On one side, we have mechanical dredgers. These dislodge and scoop soils at near in situ density. Now, in situ just means the soil is removed at almost the exact same thickness and density as it was resting on the bottom. It's not watered down. Then, on the flip side, we have hydraulic dredgers, which use erosive water flow and suction. Basically, think of it as the diggers versus the vacuums. We're going to focus on the diggers first.
Now, notice how simple but incredibly effective this mechanism is. This is a conventional clamshell bucket. It operates mechanically, dropping down completely open, biting hard into the riverbed or ocean floor, and then snapping closed to trap the material. Because it scoops the material directly, you can see how it pulls the sediment up in almost its original dense state. It's a pure mechanical lift. This is absolutely perfect for when you need to grab solid, heavy scoops of earth or debris and drop them right into a waiting barge.
And here's another incredible mechanical dredger. This is a backhoe dredge, which honestly looks exactly like a terrestrial excavator you'd see on a construction site, except it's mounted securely on a floating pontoon. Take a really close look at those vertical poles going down into the water. Those are called spuds. Spuds act as heavy underwater anchoring legs. Because think about it, a backhoe generates massive digging forces that would normally just tip a boat right over. So these spuds drive deep down into the seabed to stabilize the pontoon, giving that backhoe arm a rock-solid base to do the heavy digging.
Let's transition into Section 3, hydraulic dredgers, the vacuums.
So if the last section was all about giant shovels, we're now looking at highly engineered underwater vacuums. But before we look at the actual machines, we have a vital learning checkpoint. You absolutely must understand this one term, slurry. Slurry is a pressurized sand and water mixture created by hydraulic erosion. Hydraulic dredgers actually intentionally introduce a ton of water to the soil to turn it into this muddy liquid soup.
Why?
Well, because you can't exactly pump solid rock through a pipe, right? But you can pump a pressurized liquid slurry over incredibly long distances.
To create that slurry, hydraulic dredgers use highly specialized dredge heads. Just compare these two side by side here. On the left, we have a horizontal auger, and on the right, a vertical cutter head. Both of these are completely submerged at the bottom of the water, attached to a frame called the ladder. They rotate rapidly, applying intense mechanical force to chew up and dislodge the really hard sediment from the bed. And as they grind up the earth, a massive hydraulic pump immediately sucks that loose material and the surrounding water right up into a pipeline as a slurry. And when you need to vacuum the ocean on a truly massive scale, you use one of these. This is a trailing suction hopper dredger, or a key SHD for short. It's a fully self-propelled seagoing ship. It lowers these massive suction tubes, which are called drag heads, and quite literally drags them over the seabed while the ship is moving forward. Because it operates out in the open ocean, it uses something called a swell compensator. This absorbs the shock of the ocean waves and keeps the drag heads firmly planted on the bottom. The slurry is sucked up and stored right inside the ship in an enormous internal hold called a hopper. And get this, that hopper can hold up to 33,000 cubic meters of material at once. It's just wild.
All right, let's look at Section 4, the 4 dredging phases.
Let's see how all of this builds our complete picture. We know why we dredge, and we know the two main families of equipment used to do it. Now, let's map out the comprehensive operational process from start to finish. Every single dredging project goes through these 4 distinct phases. Think of this as the entire journey of a single scoop of dirt. First up is excavation. That's dislodging the soil from the bed using our mechanical buckets or hydraulic cutter heads. Second is vertical transport, literally lifting that material from the dark depths up to the surface. Third is horizontal transport, moving that material away from the dig site, either by loading it into a barge or pumping it as a slurry through miles of pipeline. And finally, the 4th phase, placement, depositing the material at its final, ultimate destination.
Now that final phase, placement, brings up a pretty massive logistical question, doesn't it? We are moving millions of cubic meters of underwater soil every single year just to keep our global economy running. So, once we've excavated it, vertically lifted it, and horizontally transported it, where does it all actually go?
This brings us to Section 5, Beneficial Uses of Sediment.
To answer where all that soil goes, we kind of need to shift our perspective entirely. See, historically, dredged material was viewed as problematic waste. Just muck that you needed to get rid of as cheaply as possible. But today, it's a hugely valuable resource. This shift is captured perfectly in this quote based on guidance from the U.S. Army Corps of Engineers. Most dredged material can be a valuable resource. Wherever sediment is needed, dredged material could be the source. With increasing urbanization and way stricter environmental regulations these days, it's getting really hard to just dump this material. Instead, engineers now prioritize using this sediment for a dual-purpose benefit. We clear out the channel, and then we use that dirt to build something totally new.
Just look at the real-world applications of that philosophy. That former muck from a shipping channel is repurposed for some incredible things. We use it for habitat development, creating vital nesting grounds on new islands for colonial seabirds. We use it to build recreational parks, replenishing badly eroded beaches, and even support agriculture and forestry. We literally even take this nutrient-rich sediment and use it for strip mine reclamation, bringing completely dead land back to life. It's a real game changer. We started this explainer looking at fundamental definitions, and we've built all the way up to seeing how this exact same material creates entirely new ecosystems. Our entire modern global economy stays afloat thanks to this unseen, constant underwater choreography of endless excavation. So the next time you see a deep-water port, a replenished beach, or a beautiful coastal park, I want you to stop and ask yourself, was this land actually built from the bottom of the sea? Thank you so much for joining me to explore this fascinating foundational topic. Keep observing the world around you, and I'll catch you next time.